Hello, everyone, and welcome back. Happy Monday. My name is Mrs. Fenton, and I teach at Adlai E. Stevenson High School in Lincolnshire, Illinois. Happy Monday, everyone. Today, I'd like to start out with an overview of the news that just was released kind of late on Friday about this year's exam. We have quite a bit of news that we haven't had for a while. The first and most important news is the date of the exam. So mark your calendars for Tuesday, May 19th. What's unique about this year is everybody is going to be taking the test, regardless of time zone, at the same time. So therefore, you have to look up the time that your school is in. So I teach in the Chicago area, which puts us on Central Time, which means my students will be sitting for the exam on Tuesday, May 19th at 1 p.m. This is a little chart of what the exam will look like. So remember, it's FRQ only. There's no multiple choice. And just like always, there's going to be two FRQs. There's question one, for which you will be given the traditional amount of FRQ time, which is 25 minutes. And that's going to be worth 55% of the exam. This is based on your ability to explain behavior and mental processes within authentic context, right? It's going to be similar to traditional concept application questions. And I'm going to be able to show you a sample of one of these. You can see it today. Second question is going to be about 45% of your overall score, and it's a research methods question. Again, there's always a research methods question, but this time it's only going to be for 15 minutes. So that 15-minute time frame means it's going to be probably a little bit shorter. So this is an example of what a concept application question might look like, and this was from the 2016 exam. So whenever you have a concept application, again, you're going to want to remember SODAS, so space it out. You're going to want probably 7 distinct paragraphs for this question. You're going to answer in order. Don't skip around and start with conditioned response and then double back to motor neurons, partly because Part A and Part B have slightly different instructions. And you're going to define each term and then apply it to this scenario specifically. And you might want to underline or annotate in some way. For Part A, all of these examples, all of your applications have to help actually. And in Part B, it changes slightly because you have to give an example or an application where these terms would lead to actually having a negative experience. So you want to take a look at these terms for a moment. All of these terms are covered, could be potentially on this year's exam. So these are all from units 1 through 7. This is what a research question might look like, and this is the research question from 2018. You can only fit Part A on the slide. Parts B and C are on the next slide. Those are a little bit less related to research methods. So I want to focus on looking at something like what you have here in Part A. So we have a survey that was conducted to determine the state, the physical and psychological health of high school students. And what you have here is the scatter plot. So when they ask you for the most appropriate conclusion that can be drawn from the graph, this is going to have to be correlational. This is a survey that's descriptive research, and there's no evidence of any kind of experiment here. So there's no random assignment, there's no control group. You want to be really careful in your conclusion language as you're talking about a relationship. In this case, it's a positive correlation or a direct correlation between the number of absences and stress level reported. Then it's going to ask you to apply what you see here to potentially a specific term, such as the exhaustion stage for the general adaptation syndrome. And then they finally ask you an ethics question in the context of turning this into an experiment. Just want to show you the rest of this sample research methods question, even though we're not going to go over it today. De-individuation and normative social influence are both from that unit 9 from social psychology. A little bit more about this year's exam. So it's what the College Board is calling it's an open book, open note exam. And I want to make sure that you are on the same page as the College Board, because an open note test can mean different things in different situations. Your test, just like any other year, is going to be scored by college faculty, college psychology faculty, and AP readers who could be AP psychology high school teachers with extensive experience, who are trained on grading these essays in a way that is both reliable and valid. You should receive your responses as soon probably as close to the typical July timeframe as possible. So the College Board is going to work hard to make sure that these scores are returned to you in the same timeframe as normal. The interesting thing is that your responses are going to be sent to your teacher by May 26th. And it would then be up to your teachers or your administrators if they want to use the results of your AP exam as part of your course grade or just as something formative. That will be up to your school. I want to be clear that open note or open book tests doesn't mean that they're easy. And success on this exam is not going to be about copying from notes. Looking up facts is not enough because you're going to have to be able to apply. You're designing these questions in a way that you can't just simply Google a definition and answer it. Now, there's going to be more help on the way, so you can look forward at the end of April to an exam guide, a video, and a simulation to help you get ready for this test. You are welcome on the test day to either handwrite and maybe take a photo of your responses or to type them. And you need to know also that once you finish question 1, you'll have 25 minutes for that first question. Then you're going to have about 5 minutes time to make sure you can upload it. And then you will be given question 2 for 15 minutes. During that question 2 time frame, you will not be allowed to go back and work on question 1. Okay, so what I want you to do is prepare for this exam this year the way you would prepare for it any year. Prepare like it's a traditional exam. Having your resources may save you time in memorizing, but you actually need to know how to apply the information efficiently and correctly. And this takes preparation and it takes practice. So more materials aren't necessarily better because the more time you have to spend sifting and sorting to find something, the less time you have to work on writing your response. So again, the AP exams this year are designed knowing that you have access to your notes and resources. So the questions are going to ask you to apply these concepts in new ways. Copying what you've done in the past won't produce a good, satisfactory answer, probably. Okay, this is what open note is not. Collaborating with others is not acceptable as an open note policy. You cannot give or receive aid during the exam, and the College Board is definitely monitoring this, and you will be investigated for exam security for violating these policies. In the experience of faculty, generally, when students take open note tests and they're trying to find the answers on the internet, they often earn fewer points than students who take the time to apply their own learning and develop a logical response. So the AP exams, they're going to show you, they're going to give you this opportunity to demonstrate your mastery of psychology and not someone else's. You may have access to your class notes and reference concepts, but you don't need to be spending a lot of time searching those. You need to be prepared. So here's a little list real quickly of what resources are allowed on your test. And some of these resources may be in a digital format. So they might be on your classroom site. Okay, let's get on to today's lesson. We're going to start off, of course, with a review of the practice FRQ from last Friday. It was a tough one, so excited to see how you did. We're going to cover the nervous system broadly and neural transmissions specifically. We're going to talk about neurotransmitters and how cells communicate, and then we're going to end with another practice mini FRQ. The best way you can be preparing, or one of the best ways, is to actually sit down every day and take a few minutes and try to write out this mini FRQ, and then check your answer. So just another quick review of SODAS, and I want to point out that SODAS is not the only way to answer an FRQ. It is in no way required. It's just a way to kind of help you organize your thoughts and make sure that you don't skip anything. So this was Friday's question, and we have Freddie Schmidt. That name is killing me. And you need to apply the following terms to Freddie's specific situation: epigenetics, hypothalamus, and the pancreas. Okay, so epigenetics is a pretty complicated concept. So I have a little definition here for you. And epigenetics can be something that happens within an individual's life, but these changes in gene expression can actually be turned on or potentially turned off from several generations before you. So in this example for the application, I decided to give Freddie an identical twin. With the easiest way for me to kind of make this about Freddie without having this be something that's a result of something Freddie's grandmother or grandfather did. So Freddie is nervous and he needs to review, and Patty is in the same situation. But because Patty had a slightly different early childhood, he had a worse diet, he had maybe really significant stressors that Freddie did not experience. Even though these two have identical DNA, they are monozygotic twins, they have different experiences, and the expression of those identical genes that lead to different health outcomes, which maybe makes Teddy a bit more susceptible to anxiety. So if you want to think about epigenetics, here's a tip. So it's how non-genetic factors influence how and if genes are expressed. So you can think of genetics as like the blueprint, right? The hardwired inherited genes that Freddie and Teddy have that are identical. And epigenetics is the architect, right? So the architect reading those blueprints is going to put their own stamp potentially on it. It might come out slightly different. And those are your epigenetic markers that can change during your lifetime. Next up, we have the hypothalamus, which is an important limbic system structure. It's involved in a lot of maintenance functions. It's involved in internal body temperature, fight or flight, hunger, thirst, sex drives, and it regulates hormones and regulates the endocrine system through the regulation of the pituitary gland. I decided to go with hunger. So Freddie was hungry and he's motivated to eat as a result of his hypothalamus releasing the hormone orexin. So orexin is a hunger stimulating hormone. It motivates Freddie to go out and eat. We could also talk about specific aspects of the hypothalamus potentially. So the lateral hypothalamus, when stimulated, for example, in animals, sends messages that increase the desire to eat. And finally, we have the pancreas and endocrine gland, and it secretes two hormones that together create this homeostatic balance. It's a balance of blood sugar. After Freddie eats, his pancreas is going to secrete insulin, which allows his body to utilize that glucose from the meal or store any extra for use. All right, today we're going to do a really broad overview of the nervous system and the neuron, and we're going to also talk about neural firing and neural transmitters specifically. So here we have the entire nervous system, and you can certainly break down this chart even more, but you have your central nervous system and your peripheral. And remember that the central nervous system is the brain and the spinal cord. These are all of the nerves in your nervous system that are encased in bone. So like the brain is in the skull, the spinal cord is inside the spine. And the peripheral nervous system are all the other nerves that are outside the brain and spinal cord that are not encased in bone. And they would include both sensory and motor neurons. That peripheral system is also divided into two systems. So you have the somatic nervous system, which is, it has a two-lane highway, afferent nerve fibers and efferent nerve fibers. So taking information from the brain and to the brain. And soma, the word, means body. So just the cell body is a soma. This is your body, your skeletal muscle system. And then you have the autonomic nervous system, which also has two subparts, which would be the sympathetic nervous system, fight or flight, and the parasympathetic, rest and digest. And these two are kind of opposite sides of a coin. So with fight or flight and the sympathetic nervous system, this is going to be preparing the body for action. So it's going to be everything increased for the most part: heart rate, blood pressure, blood sugar. The only thing that's decreased in the sympathetic nervous system would be anything related to digestion. Parasympathetic, think of a parachute. The parachute slows you down. The parasympathetic nervous system is returning the body. It's calming it after the autonomic nervous system response. It's going to rest and repair the body, lower the heart rate, increase digestion processes, but everything else would be lower. So here's a great image where you can see kind of the opposite effect, right? So you have the sympathetic nervous system is going to have accelerated heartbeat. You're going to have a slowed heart rate during the parasympathetic. Your body's going to slow down with the exception of anything related to digestion under parasympathetic. gave you a nice little blank slide, so if you want to practice this, you could also make another chart, and you can organize the brain into the hindbrain, midbrain, and the forebrain. You can talk about the cortex. You can actually create your own chart to help you study the parts of the brain. All right, so we're going to talk about how the neuron itself fires a message, right? We have glial cells and neural cells, and glial cells are nerve cells that don't carry an action potential. They bind and support neurons. They make the myelin, which can help speed up the message, particularly in motor neurons. They have direct contact with neurons, and they offer supports and provide nutrition and support, and they have direct contact. They're also in charge of things like removing toxins, and glial cells also are related to memory. Neurons are the basic building blocks of the nervous system, and they vary in complexity, but they all have kind of the basic aspects that you see on this example here. So if you're looking at the left side of your screen on this particular cell, that's where the dendrites are located. That's part of the cell that's going to receive the message. And that message is going to travel down the axon to the terminal branches. And at the very end of the terminal branches, you'll see the terminal buttons, and inside of those, the synaptic vesicles that hold the neurotransmitters. So this is a motor neuron. It has myelin, so that myelin sheath that covers the axon is what speeds the action potential and helps to send the message faster. One of the things that is part of multiple sclerosis, of course, is the destruction of the myelin. So myelin destruction is related to MS. Now, communication within a neuron, like the action potential itself, is an electrical signal that's moving through the neuron that's going to allow one cell to communicate with another cell by releasing neurotransmitters into the synapse. And this is a sequential process of depolarization and repolarization within the cell. So when you have a resting neuron, a neuron that's just not being activated by a message of any kind, you have an axon that what we say is polarized, right? So that polarized axon is going to prevent ion exchange. And in a resting axon, you have an internal charge of about -70 millivolts. You can kind of see that by the arrow here on the left. And the ions, you're going to have sodium ions on the outside, potassium ions, K, on the inside of the cell, of the axon. And they're basically going to stay that way, right? So you can think of it as like a salty potato chip with the sodium, the Na on the outside, and the potassium on the inside, the potato, is where the potassium ions are. And we have a -70 millivolt charge inside. And you might be asking yourself, okay, but both sodium and potassium are positive. So what's happening there is there's also some chloride, negatively charged chloride ions in the interior. Now, again, this axon is selectively permeable. So at this moment, the gates, you can think of them as being closed, which is keeping that sodium on the outside, potassium on the inside. Sometimes I like to think of it as a bouncer, kind of holding the ropes, and you can't get through. But once there's enough of a threshold is met at the dendrites, the axon is going to depolarize. It's going to do so section by section. And what happens here is the gates open. And you're going to have an interchange of ions. You're going to have sodium ions entering and potassium ions rushing out. So because of this, this is going to be the bouncer essentially opening the ropes and letting in the sodium, the crowd. But a bunch more people are coming in and far fewer people, like less potassium is leaving. So you end up with charge that becomes positive temporarily. And that action potential, that change in charge, is going to then open the next set of gates. And that charge is going to travel section by section down that axon until it reaches the terminal buttons, which is going to be what makes it release neurotransmitters into the synapse. So this image gives it to you a little bit more close up. So the neuron stimulation in step 1, you're going to have the sodium ions rushing in, potassium ions rushing out, and they're both positive. You can see those like negatives inside the cell there. Those are those negative chloride ions. And you're going to have a change in charge where it becomes more positive during the action potential. And this process is called depolarization. So when the cell is resting, it's polarized. During the action potential, it's depolarizing. Now the cell's going to have to reset. After it's released neurotransmitters into the synapse, you're going to go into this area called the refractory period, which is repolarization. And this is when the sodium and potassium pumps are going to reset that initial ion balance, and you're going to return to that negative 70 millivolts interior charge. Okay, so that's communication within the cell, the action potential. So you're starting with the resting potential with a polarized axon, and you're going to have the action potential, the firing of the cell, which depolarizes, sending that message section by section down the axon, and then repolarization in the refractory period. The cell is resetting that original resting potential. Now, communication between two neurons is chemical, and it occurs at the synapse. So you have the presynaptic cell, that's the one sending the message, and the postsynaptic cell, which is receiving the message. So you have kind of a close-up image here of the terminal button, and those little circles in the center, those tiny green dots, those are the synaptic vesicles, and the little green circles in the image are the neurotransmitters. You can see just how small that synapse is in the axon terminal button of the presynaptic cell. And you see that black area, that's the synaptic gap, and the receptor sites on the receiving neuron. So that synapse, remember, the synapse is a very, very small space between presynaptic terminal button of that cell and the receptor site on the dendrite of the postsynaptic cell. So when you're having a change in voltage at the receptor site, you have these two possibilities. You have an excitatory postsynaptic potential, or an inhibitory. And at any given time, a particular neuron may be receiving input at dozens or hundreds or maybe even thousands of synapses. And some are excitatory and some are inhibitory. And what's going to happen is if there's more excitatory postsynaptic potentials than inhibitory, and it reaches a minimum level, which is what we call threshold, and that cell is going to fire that action potential. Okay, so that was quite a bit there. Let's take a brief moment and check for understanding. Here's 3 short examples. Okay, and example 1 is asking you to think a little bit also about what Dr. Spoke talked about on Friday, the endocrine system. So chemicals secreted by glands, organs, and tissues travel long distances via the blood are hormones. Neurotransmitters, they only travel very, very tiny distances between the terminal button of the presynaptic cell and the receptor sites, and that tiny space is called a synapse. The axon is depolarized. There's an ion exchange occurring during the action potential. And finally, the peripheral nervous system that has voluntary movement of skeletal muscles, that's somatic. The involuntary movement of the glands, that's the autonomic. Okay, a couple more examples. And with example 4, you might have to think back to some things you learned in class. And while I can't imagine an AP exam question where they're asking you to just randomly list hormones and neurotransmitters, I think it's helpful for you to separate them so you don't confuse the two. So the ones that are secreted by organs, right, or brain parts, you have the hypothalamus secretes orexin, which is a hunger stimulating hormone, and the other hormones that stimulates hunger or eating behavior is ghrelin, and that is secreted by the stomach. So I listed some more hormones here. So melatonin, related to the circadian rhythm. We have some sex hormones, the noradrenaline and fight or flight. And then I gave you a little bit more than 4 neurotransmitters. Another hormone that is not secreted specifically by an endocrine system gland is leptin. And leptin is released by fat cells, and it travels to the hypothalamus, and it's one of the signals that you are full. And I like leptin as an example because it illustrates the fact that hormones, they travel longer distances, so they're slower, right? So you might eat, and by the time that leptin reaches your hypothalamus and your brain recognizes that you're full, you may have still been eating. So sometimes that signal arrives a little too late. Okay, neurotransmitters, broadly, you can look at them in terms of being excitatory. They increase the likelihood that a neuron's going to fire. They're going to create those excitatory postsynaptic signals. Or they could be inhibitory. They're going to decrease that likelihood. So let's take a look at some of the most important neurotransmitters, the ones that you're most likely to need to incorporate in your AP course. First one is glutamate. Glutamate is primary excitatory neurotransmitter, and it is the most abundant neurotransmitter. It's related to learning and memory, and specifically, it's related to a process called long-term potentiation, or LTP. And LTP is essentially the biological basis of learning or memory. And it's this idea that a pattern of repeated neural firing strengthens neural pathways. And you can think of that as synapses or synaptic connections. Neural connections are going to get strengthened by this repeated firing. And what that does is it creates a stronger memory or learning. And what long-term potentiation involves is a series of molecular changes, beginning with glutamate. And what it does is it stabilizes those synaptic connections and leads to long-term memory creation. And when we're talking about long-term memory, you need to remember that long-term memory is encoded in the hippocampus, in the limbic system. And it is sent to the frontal lobes for storage and consolidation. Glutamate can have a lot of issues as well, can cause problems in excessive levels. So an oversupply of glutamate is certainly linked to things like migraines and seizures. And it's believed that the kind of natural response, the excessive release of glutamate following a brain trauma or a stroke, is related to much of the damage that's caused. So, for example, if certain brain tumors grow, they release toxic amounts of glutamate, and that toxicity of that excessive glutamate can destroy cells that are located near the tumor. Now, we talked about the major excitatory neurotransmitter. GABA would be the primary inhibitory neurotransmitter. And low levels of this is definitely associated with things like anxiety, seizures, insomnia, and anti-anxiety medications. For example, a category of anti-anxiety medications called benzodiazepines. They are GABA agonists. So what those drugs do is they increase the transmission of GABA. So they're going to increase this inhibitory neurotransmitter, which in turn is going to create relaxation. So anti-anxiety medications, benzodiazepines, drugs like Valium and Xanax create relaxation by increasing GABA. Endorphins are neurotransmitters that inhibit pain, and they're also released sometimes with response to vigorous exercise. It's that idea of a runner's high. Adrenaline is also a hormone, not a neurotransmitter, and it's released as part of the fight or flight response. And adrenaline can also work as a pain reliever. Interesting about endorphins is, like morphine, they're a natural painkiller, and drugs like morphine or even illicit drugs like heroin, they mimic endorphins. So they work in the same way. Next up, we have dopamine, and this image here is the dopamine pathways through the brain. So you can see the various regions that are affected by the dopamine pathways. Dopamine is related to a lot of different functions. So pleasure, reward, voluntary movement, learning, attention, and has issues when it's related to over and undersupply in certain conditions. So schizophrenia, which is a mental illness that involves serious disturbances in movement, motion, cognition, perception, is related to excess levels of dopamine. How schizophrenia medications are going to work is they're going to work on reducing schizophrenia. So they're going to be antagonist drugs. I'm sorry, reducing dopamine to reduce schizophrenic symptoms. Parkinson's disease, which is degenerative and fatal and kind of characterized by tremors and problems initiating movement, is often related to destruction of dopamine-producing cells, right? So the dopamine-producing cells in Parkinson's disease are dying off. And one of the treatments that can be used is something called injections of L-DOPA. And L-DOPA is the main building block of dopamine, and injections of this can help the remaining dopamine neurons produce more dopamine, and it's going to create some symptom relief, but unfortunately, the effects are temporary. Dopamine is also related to pleasure and reward, and therefore it has an impact on action. So this image is an example of a rat who has an electrode implanted in the nucleus accumbens. So it's a region in the brain that's rich in dopamine and part of the reward circuit. And what's going to happen is, in order to get that reward of the dopamine release, the rat is going to be willing to cross the electrified grid, willing to engage in an action that causes the animal some pain in order to get to that stimulation pedal. Now, ethics in animal use, that's really something to consider when doing a study like this. I'm not sure the study needs to be replicated much more. Maybe it does. But the rats are demonstrating what their behavior would be changed by the fact that their brain is being changed with the reward that's released from the dopamine release in the nucleus accumbens. Serotonin is primarily associated with mood, and you're going to see serotonin in relation to depression. Serotonin is often in lower levels in depression. It's also related to other things like sleep and appetite. And low levels of serotonin are also linked to aggressive behavior. So medications for depression sometimes work by increasing the transmission of serotonin. Norepinephrine is interesting because this is a neurotransmitter and it's released in the brain, and it's a hormone when it's released into the bloodstream by the adrenal glands. And it's related to that sympathetic nervous system response, that fight or flight reaction or other excitatory actions. Also sometimes correlated in low levels with depression and high levels in agitated states such as mania. Acetylcholine is muscle contraction, heart rate, memory, and learning. And a lot of neurotoxins actually work on acetylcholine. So for example, something like a black widow spider bite, that venom and other neural toxins, like certain types of nerve gas, what they do is they release excessive amounts of acetylcholine transmission, and that results in muscle spasms so severe that it might actually make the individual have trouble breathing. Now, some neurotoxins also work on acetylcholine, but they work the other way. They block its transmission. So botulism poison can lead to muscle paralysis because it's going to decrease or stop acetylcholine transmission. Acetylcholine is also related to memory, and the destruction of acetylcholine producing neurons is related to some of the memory loss that is part of Alzheimer's disease. So one of the medications that's used to treat Alzheimer's disease, what it does is it blocks the action of an enzyme that naturally breaks down acetylcholine in the synapse after a cell fires, thus allowing greater transmission. So it's another way of having it work as an agonist drug. Okay, so let's take a look at some of these examples of these neurotransmitters in real situations. Okay, let's see how you do. How you did. So sometimes the problem with opiates and opiate addiction is that the brain gets so used to these synthetic opiates, the heroin and the morphine, it stops producing its natural endorphins, which can lead to withdrawal and cravings. With number 2, dopamine in low levels is associated with the movement problems of Parkinson's disease. And you might remember also that excessive levels of dopamine are linked to positive symptoms in schizophrenia. Okay, so today we did an overview of the 2020 online exam. And we're going to keep giving you more information as soon as it becomes available. As soon as that information about the simulation and the preparation guide are released. We reviewed that previous FRQ with genetics, epigenetics, and the endocrine system. We looked at the nervous system broadly, the action potential, and how neurotransmitters impact behavior. So what we're going to do now is I'm going to give you an FRQ to practice. It's going to be on the next couple slides. We're going to go over this when we meet again tomorrow. It's a mini FRQ, and this one has some research points and some concept application points. So it's a little bit of a combination FRQ to give you some practice with both types that you'll see on the AP exam. So the first part is just a description of the study. The study found that teens who smoked e-cigarettes were more likely than other teens to start smoking regular cigarettes. Teens ages 12 to 17 who never smoked a regular cigarette were asked to report their use of e-cigarettes. 1 year later, the same teens were asked if they had smoked a regular cigarette. 4.6% of the participants 1 year later had tried a regular cigarette. However, 18 to 19% of those who said they had used e-cigarettes at the beginning of the study had then gone on to try a regular cigarette. So if you look at part A, you're going to look at the most appropriate conclusion. You want to think about what type of research this is that you're looking at. And I'm going to ask you in part B to talk about how researchers have studied dopamine and the reward center. And then in part C, this is where it's a little bit more complicated. You're going to give a more sophisticated answer here. So we're going to use a specific physiological mechanism to explain the two opposing tendencies, right? So for neural firing and the autonomic nervous system. Again, we have another quick reminder that if you or someone that you know is having trouble accessing the internet or device that you need for the exam, please fill out this survey, reach out to the College Board. Thank you so much for watching. I hope you'll join us again tomorrow, and be sure to practice that mini FRQ. See you tomorrow. Take care.